loves chemistry 'cause it's fun. That makes it crazy, then he's the one to teach you chemistry 'cause it's fun. He's chemistry coach. He's chemistry coach.
Hey, what are you guys doing over there? Are you like bouncing off of each other like a bunch of molecules? What is this, some sort of rave? Golly, how is a guy supposed to get any sleep around here? You chemistry students, go back to work. Hi, welcome to Chem Coach with Coach Powers, where my goals are for you to have fun learning chemistry, where you can discover the wonder and beauty of chemistry, and where you can use the things that I'm teaching to help you have success, whether it be in an everyday application or perhaps a test that you might be taking. I'm here for you. Today we're going to learn about collision theory. Collision theory is kind of like those little sticky men or sticky animals that you take and you throw against the wall, and then they actually stick sometimes. Sometimes they don't. Why is it that they don't stick sometimes? Well, you might not throw it hard enough. They might be filled with too much gunk from having fallen onto the floor many times before. Or perhaps they didn't quite hit in the right way. That's a lot like collision theory. Today we're going to talk about the role of energy and collision and orientation in a chemical reaction. And so by the time you're done, I want you to be able to describe 2 collision conditions necessary for chemical reactions to occur. Now, some people talk about 3 conditions necessary for chemical reactions to occur, but the first one is that they actually collide. So that's what we're going to be doing today. And what I like about the collision theory is that it kind of fits seamlessly into kinetic molecular theory. It's fun to see how all these particles in motion are actually interacting. And collision theory was originated when they started noticing that the rates, remember we're going to be talking about rates here in future lessons, that the rates don't quite match up with what their expected values were. And so a couple scientists started thinking, well, maybe there's something more than just collisions that are involved. Maybe there is orientation involved, and maybe there is speed involved, or kinetic energy. So, as you can see on the screen, for a collision to be successful, the 2 characteristics that need to be present are favorable orientation and sufficient energy. They've got to be moving fast enough to actually have that energy to break bonds that they're currently in and then form new bonds. And if they're not quite oriented right, because remember, some molecules are pretty complex. One little guy might come in, hit a weird spot, and it might not work. But if it hits just the right spot, then they can combine. And so you got to think about the orientation of the molecules as well. So remember, sufficient energy has to do with something called activation energy, and we're going to talk about the activated complex as well. That'll be on our next lecture. So if you have enough energy to break the bonds and then form new ones, that's our E sub A, which is our energy of activation. Okay? And that's the maximum amount of energy that's required in order for those reactants to form that activated complex. Again, we'll go into that in a little more detail tomorrow. So if you look at this slide, you can see that over on the left, you've got an orientation that seems to be just right. But those small little dotted lines are showing not quite enough energy, and so those don't actually react. And so you have the 2 reactants coming away just like they started coming to, they come away. In the middle box, you'll notice that the orientation is not quite correct. So when they collide, even though they might have enough energy, which is showed by those longer, darker red dashes, they still don't react because the orientation is not correct. And finally, in that last little box, you can see that the orientation is lined up, the speed is there with those dark red lines, and then we get some new chemicals forming. So orientation and speed. In this example, you can see a compound of NOBr colliding with another compound of NOBr. No, brother. Sorry. And you're going to end up getting 2 nitrogen monoxide molecules and some bromine. Now, you can notice that in that first line that they're aligned correctly where the bromines can actually connect. And then in the second example, you can see that the nitrogen and oxygen are coming in and they're not oriented correctly. I've also made another video for you to look at, and you can see this little animation showing you how one of them has the right speed and the other one doesn't have the right speed, and one of them has the right speed and orientation. So, pretty quick and easy lesson today. Just learned a little about collision theory, and so now you should be able to describe the 2 conditions that collision theory needs in order for chemical reaction to occur. If you don't understand anything about this, go back and rewatch, and don't forget to like and subscribe so that we can get you hooked into the next video as soon as it comes out. All right. Have a great day.